record this, minimize it, and blow this thing up. Is this the only problem we have to look at today?
Yeah.
Okay. Well, this shouldn't take an hour.
Mm-hmm.
All right, L1 and L2 are parallel. I'm trying to figure out if I can do this without redrawing it, because we have to start putting some angles on some of these angles that we know.
Mm-hmm.
Okay? Like, for instance, E.
24.
Okay? So, go ahead and write that down for E. Maybe I can get away without redrawing it. In fact, let's start with A. What's the measurement of A? Because L1 is parallel with L2, then A has to be 48. Notice that if I tried, I couldn't draw something where they weren't equal. If I have a circle and I put a parallel line through that and a parallel line through that, notice that that arc has to be the same as that arc, no matter how I do my parallel lines. It doesn't matter where I want to draw them. I could draw them like this, and I could draw it like that. That arc's going to be the same as that arc. Okay? So A has to be 48 degrees, just like what its opposite. Now usually you can kind of figure these out in order, and if we do them in order, we might be able to get by without me having to redraw the whole thing. If A is 48, what is B? L2 is a diameter line.
84.
Correct. Because A plus 48 is 96, supplemental to 96 is 84. Let's go ahead and label B. Now let's look at C. Can we figure out C? If we knew J, we could figure out C. I don't see how we're going to figure out C in order, though. In other words, I don't know that we can do C before we do D, even. Or E. Let's fill in E. Let's leave C and D for a second. We know E is 24. What's F?
156.
F, angle F.
24? No.
Always look at it and make sure that your answer makes sense. It looks about 90, right? We're talking about this angle right here, F.
Yeah, I know.
Okay. It is 90 for two reasons. If you inscribe a right or a triangle inside of a semicircle, it's always a right triangle. So for the same reason, I is also 90. F is 90 and I is 90.
Wait, why again?
Well, look at the arc that F intercepts. It's a 180-degree arc, right?
Yeah.
It's a semicircle. Well, if it intercepts a 180-degree arc, it has to be half of that measurement. So it has to be 90. Same thing with I. I intercepts a semicircle, also a 180-degree arc. That's why the triangle is always a right triangle if it's inscribed inside of a semicircle. Okay. So we know I.
We can find G out.
We can find G out? Oh, because we know E. Yeah, what's G? E is 24, so G has to be 66. So now we have the top half of that circle solved. Now we just got to look at the bottom half.
This is 74.
Right. So this is 74. We also know that 74 equals 1/2 of that arc, which we don't quite know yet, minus that arc. Ah, we can figure that out.
Isn't it, can't we find K out because it's
Well,
an isosceles triangle?
if we look at that 74-degree angle, this is going to solve almost the whole triangle, I think, if we solve this. 74 equals half of A plus B plus 48 plus C. So what is that? What's A plus B plus 48? That's 180. Plus C. That's the big arc, right?
Yeah.
You with me?
Mm-hmm.
The little arc is D. However, there is a relationship between C and D. What is it? Can I write D in terms of C? What is,
Add up to 180.
they add up to 180. So instead of writing D, I'm going to write 180 minus C.
Doesn't that just cross out?
No, we got 180 plus C minus 180 minus C. 180s go away, but we end up with 2C. So we get 74 equals 1/2 of 2C. C is 74. What's D?
Um, 106.
Okay, so now we've figured out the measurement of all the circle, all of the outside. I wonder what they mean by K. Oh, they mean that angle.
Oh, we know that's 37.
It's half
We
of
know
74, right. Half of D.
And those all equal 180. Right?
Well, what all equals 1? Oh, well, K plus that angle there. Well, now hold on a second. K is this short angle. Yeah, K is half of that arc D. So what have we yet to solve for? We've solved for I. We haven't solved for J and H yet, have we?
Yeah, we have.
Well, J is going to be half of C. So yeah, J is 37. And we know I, we know J, now we know K. We've solved it, the whole thing.
Wait, how do we know K?
K is if you have the following situation. You have a bottom tangent line and there's an angle like that, then that angle is half of this measurement.
Oh.
And I think that's what we're looking at. If you kind of look at it, rotate the thing a little bit, or rotate your head to the right, K is that angle 1. And the arc that is, the measurement of that arc is whatever D came out to be. 106. So K is half of 106. First I couldn't figure out why L3 and L4 were on there, because they're not perpendicular, they're not anything. And if I didn't ever see that 74 degrees at the bottom, now it makes sense why they're on there. They're necessary. We would not be able to solve this problem for C and D without L3 and L4 and that 74 degree angle. Now, only one we really didn't prove was A. And I don't know that there's a theorem for A or regarding parallel lines, but I'm quite certain. Here we go. Because L1 is parallel to L2, you see where my thing is pointed?
Yeah.
That's angle E, right?
Yeah.
Because of those lines being parallel, those are alternate interior angles. Well, E cuts out a 48 degree arc, so that angle has to cut out a 48 degree arc if it's the same as E, and so A has to be 48 because of that. That's why A is 48, because of the arcs that are cut out by the same angles. It's very common to get a problem where you'll have two different angles, but they cut out the same arc. And from that, you can figure out that the angles have to be the same. Now, is there anything we did here that you don't understand how we did it? All of the letters.
I don't think so.
Okay. So, what do you want to do now?
I don't know because he didn't give us any homework.
You have are you preparing for your final now?
No, this is a test.
This is just a quiz yet? You haven't gotten your final material yet?
No.
Well, let's just call it a half-hour session today, and if you don't have anything to do, there's not much we can do.
Yeah.
Okay. You got any questions about that first problem, the one we had the other day? That's the problem. You see it? Notice that all you have to do mentally is visually eliminate one of the circles, one at a time. Let me show you what I mean by that. When I first drew it, I had eliminated this circle, right? So the only thing we were looking at was the tangent line AB and the secant line AD. And CD is that chord that is common between both of them. So if I didn't have this circle here, I would have this theorem. That's theorem 10.17. In other words, whenever you have a circle and you have a tangent line and a secant line, then this line, x squared equals y times y plus z. That's theorem 10.17. The tangent line squared equals the part of the secant line that's outside the circle times the entire secant line. Well, that's the situation you have if I erase the big circle. So I would have AB squared equals AC times AD. Well, now watch what happens when I erase the little circle. Now I have this tangent line. So this measurement right here between that midpoint and this tangent point, we'll call it AZ. AZ squared equals AC times AD. So you get AZ squared equals the same thing, AC times AD. Well, if in your proof, if you have two things that are both equal to the same thing, then they're equal to one another. So from these two statements, you can say that AB has to equal AZ, which means A is the midpoint between B and Z. All right. Quade, I'll let you go.
Okay.
And let's see, I think we have another one tomorrow, or let me just double check here.
Yeah, and I think we get our things tomorrow.
Okay.
Okay.
That currently is a half hour. Is that going to be enough?
Yeah.
Okay. And I'll change this one to be a half hour also.
Okay.
Instead of the hour. All right. I'll talk to you tomorrow.
Alright, bye.